Welcome to Study Loop.
We're told that a spotlight on the ground shines in a wall 12 meters away. A man 2 meters tall walks from the spotlight towards the building at a speed of 1.6 meters per second. We're asked to determine how fast the length of his shadow is decreasing when he is 4 meters from the building. So to understand this problem, I want to draw a diagram. Well, intuitively, we know that the man's shadow will be shrinking as he walks away from the light. Now I'll draw a diagram. We have our light here. Then we have our man, who has a height of 2 meters. And then we have our wall. We don't know how tall the wall is. So the man is walking from the light towards the wall. Now the shadow is going to be as tall as this hypotenuse is on the back wall. Now we know that the total length from the light to the wall well, we're told this is 12, and this is in meters. And the distance from the light to the man, let's call this x. And the distance from the man to the wall, therefore, well, at this instant, we're told that he's 4 meters from the building. And I'll call the height of the shadow on the wall y. To understand this problem, we should use similar triangles. So the man forms a right triangle with respect to the floor and the light. His shadow also forms a right triangle with respect to the floor and the light. And the angle at the light is the same. So by similar triangles, it follows that x over 2 is equal to 12 over y. In other words, we have x times y equals 24. Now we want to find dy dt. To do this, we'll differentiate with respect to t. By the product rule, we have x dy dt plus dx dt times y equals 0. Solving for dy dt, dy dt equals negative y over x times dx dt. And we know that the man is 4 meters from the building. So x is equal to 8, and dx dt, we're told, is 1.6 meters per second. Now we want to find y, but we can use our original equation again for similar triangles. So if x equals 8, then y is equal to 24 over 8, or 3. And therefore, dy dt is equal to negative 3 over 8 times dx dt, which is 1.6, which is negative 0.6. And the units are in meters per seconds. And so the length of his shadow on the building is decreasing at a rate of 0.6 meters per second. It's decreased because we have a negative.